Hello, good morning. This is Kodan Ram Yashwant Kumar Ramadagu. Today's project is about implementing a SOBEL filter to perform edge detection on a image. This is the in this we are going to implement first we are going to implement the HPS for the different images given, and we are going to record the time for the processing. We are doing these steps individually and collectively. I mean, individually we are doing for each and every image separately, and for the collectively we are combining all the images in a single folder, and we are doing this process. We are repeating the same process again. First we'll we'll check with the C code now, and this is the image resolution for the images, and this is the row and column for the for the pixel according to the pixel. And first we are implementing the Batman image, so we have uncommented that, and we have commented the Lena and boat for in the C code, and this is the size of the buffer, and this is our global variable buffer unsigned we are using this, and this is the Sobel filter main function. uh, Here we are using that same buffer, and these are the rows and columns. This is the matrix gx and gy are the matrices, size of the matrices, like pixel sizes we are going to implement. These are the our header files, and this is our key macros and all. These are the bmp file of which we are allocating to the memory and all. We are printing this print statements, and all. This is again the main C function. This is the Sobel function, printing our C statement, returning the code. Now let's move on to the embedded command shell. Now we are in the individual folder. These are the three files located in the folder. Now we are going to do the Batman step. In the Batman file, there are the three files. One is bmp file, one is make file, and the C file according to the particular image. Now we are running the make command. See, we have generated the .o file and the Batman file. We do have to copy this file into the flash drive. We are repeating the same steps for the Lena and the boat. In the boat we have only these three files, the same according to the Batman. But there are Batman. We have commented the Batman and Lena. We have uncommented the boat file, boat thing. We are running the make command for this. As you can see, we have generated the sobel.o and boat file for the to flash into the to get the output file from the FPGA. We are repeating same step for the Lena. So we have generated the all the files for the all the images. We are going to flash these to this thing. We are going to flash this to the FPGA board through USB thumb drive. Now we have entered to the terraces terminal. Here we are now first enter, log into the root command, and we are detecting the USB thumb drive, and we are, and after that we are mounting our thumb drive to the, we are going to mount the thumb drive to the flash drive, so the SOC board, and we have entered to the Batman folder. Now we are making the output file for the Batman. It will take a while. As you can see, we got the output file for the Batman, like I mean the filtered image by using SOBEL filter, and we are doing same steps for the boat and the Lina. You can see that we have only 5 files in that. Now we are going to make the output BMP file for the Lina. It will take hardly less than a second. This is about the first part, individual, and this is part 1.1. We have generated the individual HPS by using HPS. HPS individual files. Now we are going to do the combined HPS. You can see that this is the output file after the filter, after applying the filter for all the three images. You can see here. Same, we got the output file for the Lina. This is the output file for the Lina. That's all about the part 1, individual. Now we are doing the collective part. Here we are going to implement all the images in a single folder, uploading all the entire collective folder, and we have only the same, we are using the same C code. For the collective we have changed some of the parts, like we have removed the you can see the outputs and all. I'll do the steps one on one now. Now we are doing the HPS collective part. For that we have written the C code according to the requirement, and we have these three images and one make file in the project folder. Now we are going to implement the same thing. We are generating the make file for the combined thing. As you can see that there are three image files and one make file and one .c file. We are running the make command. As you can see that you got the SOBEL file and the .o file. We are going to flash this to the USB thumb drive and flash this folder to the USB thumb drive, and you are using by using this we are going to implement by using a FPGA board. We are implementing the combinedly. So we have imported the files to the USB thumb drive, and we are going to connect it to the flash FPGA board. As you can see that we are connecting it to the FPGA board. Now we are I'll do the steps and show you the thing. We have followed the same steps which we have done in the part 1 individual thing, but we are now doing the collective part. There are total of 6 files in the 7 files in this, 3 BMP files and one .o file and .c file, and one make file and one SOBEL file. To it will generate you the files, output file, out.bmp files. As you can see that the runtime is around 45 seconds for Batman, and for the rest of the thing it is taking less than 1 second. This is for collective part. Thank you. Now we have entered into the part 2. In this part 2 we are doing the Sobel hardware accelerator using the FPGA board by using with the help of RTL Verilog code in the through the HPS. Uh, we have using the same code according to the which we same base code for the according to the homework 9. These are the inputs and outputs. We have made some changes in this code. uh, in the platform design we have given the pin connections according to the requirement and all. We have added few pins like Sobel input, and Sobel output, and the FPGA master pins. Sobel input is the this pin is basically an output from the HPS, and this is the output from the input pin, and this is the master pin which we are building the bridge from the HPS to FPGA. This is a bridge pin, like a bridge pin. And now we have generated the file. This is the Sobel filter connection pins through the hardware, and we have separated the Sobel and C code, Sobel filter and the RTL code. As you can see that there are changes in the C code as well, HPS code and the FPGA code. We have divided the code according to the requirement. We are running the make file. As you can see the code got compiled and we got 0 errors. Now we are going to do the same steps. We are generating the make file for the combined thing. As you can see that we have generated the make file and the .o file for the hardware acceleration. Now we are going to flash the USB drive. First we are going to flash the FPGA board, and then we are going to update the SOF file. We are flashing it the into the FPGA board. The see, you can see the 100% result. And now we are going to do the HPS part. We have already flashed the board by using from the quarters prime. Now we are going to do the thing, generating the, we are making the Sobel filter images. As you can see that board file took 0.44 seconds, and the Lina file also took the 0.44 seconds. The runtime for the both the images is same, and for the Batman it is taking a while. As you can see that it will take around 45 seconds to 60 seconds. It took 31 seconds to generate the out.bmp file. See, the out.bmp file got generated for all the three images. This is about the project. As you can see, the combined output results are here. This is the Batman image from the from the quarters generated and the after flashing the board, and this is the boat image, and this is the Lina image after for the part 2. From hardware and software accelerator, we are going to implement the we have implemented the hardware and software system with the HPS read through the BMP files. That's all by the using the hardware accelerator to be the processor to be sent to file and send it to the hardware accelerator to be processed like this. That's all about this project. Thank you so much.